Hello, geometry. So today we're going to be working on section 1.4, which is reasoning and proof. And we're going to start with a few definitions. The first is conjecture. Conjecture is basically a guess, but it's an educated guess. It's not throwing something out of left field. It's based on what you know and logical reasoning. What do you think is true? All right, now there are two ways we can prove whether our conjecture is true. We have inductive reasoning. That's the process of reasoning that a rule or statement, let me back up and give that a little easier definition. So inductive reasoning means we're going to look at specific cases and use a specific case to prove something is true. So we're going to have actual numbers. We're going to look at a specific triangle or a specific square or a specific set of numbers and prove it's true. The problem with that one is we've only proven that it's true for that one example. For example, I could say, you know what? 2 plus 2 equals 4. And 2 times 2 equals 4. So then if I take a number and add it to itself and then multiply it to itself, I'm going to get the same answer. But that's not always true. For example, if I do 3 plus 3, that's going to equal 6. And 3 times 3 equals 9. So the danger of inductive reasoning is that you may come up with a rule that doesn't actually work for every single scenario. The other option for proving a conjecture is using deductive reasoning. Deductive reasoning uses logic to prove whether all cases are true. So in this case, we might come up with a general rule. This is when you start seeing things like using variables instead of actual numbers, that we want to come up with a rule that makes it true for the every possible scenario. So what do we actually, or how do we actually use that? We're going to get to that in example 1. I've got one more definition for you, a theorem. A theorem is basically what, after we've proven our conjecture, that conjecture becomes a theorem. So once we've proven it's true for everything, every scenario, we can now call it a theorem. This is what you might have called a rule in earlier math classes. All right, let's jump down to example 1 and go over how exactly do we prove these? How do we turn a conjecture into a rule? Well, we're going to make a conditional statement is one way, and these are always written if then. So if is our hypothesis, the if part is our hypothesis, the then part is our conclusion. So the example they use is we say if 3x minus 5 equals 13, that's my hypothesis. That's the piece I'm being given. Then I can solve that out. Add 5 to both sides, I get 3x equals 18, divide by 3, and I get x equals 6. That's my conclusion. That's my then statement. So there are quite a few properties that you probably already know. Like internally, these are going to make sense to you. The addition property of equality. If A equals B, then A plus C equals B plus C. So what this means is if A and B have the same value, I can add A to a number and add B to that same number, C, and I'll get the same answer. Okay? So if I have a cookies, let's say, all right? I have a certain number of cookies. And 2 of you students each have cookies, all right? So you each have the same number of cookies. If I then give you each 5 more, you two will still have the same number of cookies. If I give you 50 more, you still have the same number of cookies. That's the addition property of equality. The subtraction property of equality just turns that plus into a negative, into a minus. So same thing, if student A and student B have the same number of cookies and I take 5 away from you, each of you, you will still have the same number of cookies. Multiplication, if A equals B, then AC equals BC. So if student A and B have the same number of cookies and I double how many you have, you still have the same amount. Division property of equality, if you have the same number of cookies and I take half of each of yours away, you still have the same number of cookies. Reflexive property of equality. This is that reflex answer. If I ask you, what does 2 equal? Most of you will say it equals 2, right? Something, some number, some value will always equal itself. Symmetric property of equality, I know you guys have used before. I've seen you use it. A equals B, then B equals A. It doesn't matter which way I can flip them. If they equal each other, it doesn't matter which one I list first. Transitive property. Student A and student B have the same number of cookies. And student B and student C have the same number of cookies. Then student A and student C have the same number of cookies. All right, so if two people equal a third, so in this case A and C both equal student B, then A and C are going to equal each other. And the substitution property says if A and B are equal, then anytime I see A, I can replace it with B. So if I had a formula that said 5A plus 7, I can substitute that A and replace it with a B. That's a B. So if two things equal each other, they're interchangeable. So why do we use those? Well, we're going to use them as rules to help us prove something. So we can see in example A, they gave us this equation, and we want to use deductive reasoning, so use our rules, our properties, to solve out for x. So what did they do first? Well, they used the addition property of equality and added 4 to both sides. Then what did they do? They used the division property and divided by 3. It says 6 equals x. Well, we don't usually write it with the number first, we usually write it with the variable first. So they used the symmetric property to just flip-flop it and make x equals 6. Let's try example B together. So we've got our formula. Our first step to solve this would be to do PEMDAS. You guys are all familiar with PEMDAS, our order of operations. But when we're solving an equation, moving something from one side to the other, we're going to do it in reverse. So we start with any subtraction addition. Well, I can subtract that 17. So I'm using the subtraction property. And let me see if I can make my pen a little thinner so I can write these where they're easier to read. Okay, here we go. So subtraction property of equality. And 9 minus 17 is going to give me negative 8. Which that's a typo, we don't need that line. So then what do I need to do to get x alone? Well, I need to divide by that negative 4. So that was the division property of equality, because I divided. Negative 8 divided by negative 4 is positive 2. And again, we swap it so the variable becomes starts the equation. So we just flipped it, and that's called the symmetric property of equality. So what you're going to do for any of these problems is simply solve out the problem, solve for x, like you did all last year in Algebra 1. but tell me what steps you took. So they're all going to be properties of equality. If you subtract, you write subtraction. If you multiply, you write multiplication property. All right. That's it for today. I'll see you guys later.